welcome to another series of the MCA physics class. In this section of the physics class, we are going to be talking about measurement. First of all, what is measurement? Measurement is defined as a technique used to measure different quantities in physics. In physics, there are three basic fundamental quantities. The first one is length, and the second one is what? Is mass. And then the third one is time. So these are the three fundamental quantities we have, which is length, mass, and time. These are the three basic fundamental quantities we have in physics. The unit in which they are measured is called fundamental units. Now, other fundamental quantities are electric current and temperature. These are also fundamental quantities, but they are not the three basic fundamental quantities. We are going to look at their units. Like the unit of length is meters, and the unit of mass is kilogram, while the unit of time is what? Seconds. Now, if you look at the board, we have the five fundamental quantities, their units, and the symbol of their unit. The first one I have there is length. For length, the unit is meters and the symbol is m. While the second one is mass, the unit is kilogram, which the symbol is kg. Then the third one is time. The unit is seconds and the symbol is s. And the fourth one is temperature. The unit is Kelvin and the symbol is K. Then the fifth one is electric current, which is measured in ampere and the symbol is A. These are the five fundamental quantities that we have. We have some other quantities like mega, kilo, centi, or milli, etc. They are used to indicate multiple and submultiples of these units. This mega, kilo, centi, milli, they are used to what? Indicate multiples and submultiples of these units that we have just measured. We are going to talk about derived quantities. What are derived quantities? These are quantities derived from fundamental quantities. Example of that is area, speed, and density. Let us see what we are talking about. Area and speed and then density. So the quantities you have on the board there, which are the derived quantities, are as follows. Area, the derived unit is meter squared, and the symbol is meter squared. And then the second derived quantity is density, which is measured in kilogram per meter cube, which is kg per meter cube you are seeing there as the symbol. And then speed, which is measured in meters per seconds. The symbol is written as meter per seconds, which is there that you are seeing meter/seconds. Then we have force. Force is measured in Newton. That's the derived unit. The symbol for Newton is N. Another unit for force is kilogram meter per second squared. Why is it kilogram meter per second squared? We know that force is what? Force can be written as what? Force is equal to mass times acceleration. Now, the unit of mass is kilogram, and the unit of acceleration is meter per second squared. So if we combine it, the unit becomes kilogram meters per second squared. I believe we have been able to understand the one for force. Then energy. Energy, the derived unit for energy is joules, which is the symbol is J, or we can take it as Newton meters, or it can also be kilogram meters squared per second squared. So these are the units for all these derived quantities that we have measured. Now, the next thing we are going to talk about is measuring instruments. The next thing we are going to talk about is measuring instruments. Now, what is measuring instruments? Measuring instruments are instruments used to measure different quantities in physics. Example of such instruments are 1. The spring balance. The spring balance is a good example of that. And the second one is beam balance. As we move on further in the class, I'm going to show you the diagrams of all these measuring instruments. The first one, like I said, is spring balance, and the second one is beam balance or chemical balance. While the third one is hydrometer. and the fourth one is thermometer, and the fifth one is micrometer screw gauge, and the sixth measuring instrument is vernier caliper, while the seventh one is meter rule. If you look at these instruments I've measured, they all have uses. They have their different uses. The first measuring instrument we have on the board is spring balance. And if you look at the diagram on the board, we have 3 diagrams of spring balance on the board there. They are all used for measuring the weight of an object. This is the spring balance diagram. Now this is the spring scale. This one is called the spring scale. Spring scale. And this is the load. So as you put the load on this hook, it drags the hook in the spring downward. And as it drags it downward, the weight will now be measured inside the calibrated values which you have inside the scale, spring scale. So if the mass of this object is 20 kilogram, it's going to indicate at the spring scale. Let's assume that the mass of object is 20 kilogram. So on the scale, what you are going to see there is, you see 20 kilogram there. So that shows that your spring balance has recorded your mass or the weight of an object. Then the next thing we are going to talk about is the beam balance. Now the beam balance is used for measuring mass of an object. Like I said, I told you that the spring balance is used to measure weight, but we also have another one which is called the beam balance. Now the beam balance is used to measure the mass of an object. Now if you look at the diagram on the board, that's a good example of beam balance. You'll see that the beam balance has 2 scales where the masses can be placed. The first one on the left and the first one on the right. The 2 scales there, they are used to measure your masses M1 and masses M2. Like the first one there now is measuring your what? Mass M1. And the second scale is measuring your mass M2. That means in this case, if we are measuring the 2 masses, when we place the 2 masses, let's say the first mass is 35 kg and the second mass is 45 kg. When you place it on the mass scale, the scale will now record the total masses of the 2 bodies. It's going to record the what? Record the masses. And what are the masses? The masses will now be 35 kg plus 45 kg. With this diagram, when you place the object there, then you will see the reflection of the mass, the total mass of the object on the calibrated, we have what we call calibrated segments. That's the calibrated values of the beam balance. So the calibrated values tells you the measurement of the 2 masses. So that is that about our beam balance.